Hope everybody's had their cup of coffee. I know it's the afternoon, but I think we'll make it exciting for you. I am Tushar Katarki, and with me I have Sean Cohen. I'm a product manager at Red Hat in what we call as the storage and the big data business unit. And Sean is in the cloud and the business unit, virtualization business unit. We'll tell you a little bit about ourselves in a bit. Today's presentation is going to be about an exciting topic, hopefully, integration of storage, virtualization, and OpenStack. Hopefully, you are all interested in that topic. To tell you a little bit about myself, I have about 14 years of industry experience, software development, product management, project management, both storage as well as server side. I think majority of those 14 years were spent at Sun and Oracle when Oracle bought out Sun. So I'm kind of familiar with this area, but most importantly, the topic is also very relevant to my experience in the sense that we are going through this convergence. We're going to talk about this intersection of storage and virtualization and OpenStack and private clouds, and it's very exciting for me personally. Sean, do you want to say a couple of words about yourself? Okay.
So good afternoon, everyone. I hope you hear me well. I'm excited to be here. This is my first summit. And for some of you, I know that's the same experience. And I just want to share some of my feelings before we start. You heard that pretty much throughout the days already in the first keynote. This year, the theme of our summit is all about connect. And it's not the chance that we're sitting here together and talking about the integration of bringing the worlds together. Now, for those of you who already are there and you attended the keynote this morning as well, you heard that we referred to virtualization already as traditional, right? A few summits ago, this was the future. I'm still young, but for me, it's already jumping between lifetimes. And virtualization has actually become traditional. And we're right on the time where everything is changing. The IT is changing. And now we're actually looking to bridge the world. It's not so trivial as you thought. I just stepped out of another colleague presentation who just mentioned, OK, I have a VM on VMware that I would like to move to Amazon or from Amazon to VMware production. How the hell am I going to do that, right? So we need to build the bridges. We need to lay down the infrastructure for us actually to get from legacy, traditional environments, enterprise applications, towards the new era of the cloud. It doesn't matter if it's a private, hybrid, or public cloud. And this is what it's all about. So today, we're not just going to talk. We're going to also demonstrate. And the second part of the presentation, I'm going to show you how it integrates already in production. OK? Let's roll.
Thanks, Sean. I think, so he touched about the agenda. So here it is. I mean, we can talk about some of the forces that Sean mentioned. Then we can talk about why we are saying IT environments are going to be diverging, especially because of virtualization, private clouds, hybrid clouds, and public clouds. And we're going to see how we're going to use 3 Red Hat technologies to bring them together: Red Hat Storage, Red Hat Enterprise Virtualization, and Red Hat OpenStack. I mean, obviously, this is not enough. I mean, there is more, but obviously, we want to cover these 3 pieces in this presentation, so we keep it focused, and we kind of have, we can cover it in 1 hour. And finally, the couple of last things, we're going to cover a couple of use cases, both from like a big data scale out, massive scale out, how do you do that, and also scale down. I mean, a lot of people have stopped by the booth yesterday, and they said, hey, scale down is relevant too, and it's not just scale out. So we're going to talk about that. And then we'll summary. And then the Q&A, ideally, we'd like to do it, keep it interactive, but given that there are so many people, and we do want to cover this in an hour and 45 minutes really, and so we can have the Q&A at the end in the last 15 minutes. So if you can hold your questions, I'd really appreciate that, and we'll have plenty of time to cover Q&A. So with that, let me move to the next. So we talked a little bit about, so at a very high level, we are saying, everybody agrees, I hope agrees with this. I mean, IT is changing, and IT is changing because the lines of businesses are demanding change. Their customers are demanding change. Traditionally, what it was IT provided the infrastructure in the form of a data center, and then the businesses used it, applications used it, or customers used it. But what is happening increasingly is that because of reasons of speed, be it flexibility, or be it ease of use, the business owners are saying, we need a change, right? And now IT is working with these business owners. So we are getting into things like public cloud. Oh, I want to go and develop in the public cloud. I don't want to worry about infrastructure. We are worrying about, public cloud is not secure enough. So we are talking about public cloud. We're talking about private cloud. We're talking about data centers. And so this is a phenomenon that is happening. I mean, this is not something that we're taking it for granted, at least for the purposes of this presentation. I hope you agree with me. So what this is leading to is what I would call, can't call it islands, but basically you have your traditional IT, which we use the term traditional. We use virtualization over the past few years to achieve consolidation and get the efficiencies there. Then you might be looking at, hey, how do you make some of this self-service? How do you take it to the next level? How do you get to a truly private cloud, truly self-service, with everything being virtualized, everything being self-service? It's not just compute, it's storage, it's networking. So you might be thinking about that in terms of private cloud. And some of your lines of businesses or developers or even customers might be thinking about, hey, let's develop things in the public cloud. And the reality is that every IT organization, or a majority of the IT organizations, are today somewhere in this range, right? I mean, you have a bit of virtualization. You might be more mature in private cloud. You might have more public cloud. But they have some pieces of these three things that majority of them have them. And I think the question that most of them, I'm sure you agree with me, are asking is, OK, this is great, right? I mean, virtualization does its thing, in terms of consolidation. Private cloud is providing these services. Public cloud is taking out some of the uncertainty out. But how do you bring it together? The reality is that we all have the three things. Even if I don't have it today, I may have it tomorrow or in a few months or the next year. Maybe I'll do an acquisition. Those guys, maybe they have a private cloud or a different virtualization technology, or they might be in public cloud. So how do I kind of bring them together? How do I bridge this gap? Just one example of this could be, you have a developer or a development group which has done all the development in the public cloud, right? AWS, pick the most popular one. And now, they want to go into production with this application, but they obviously cannot do it on AWS, maybe because of security reasons. It's been a lot in the news of late, or it's maybe because you have regulatory reasons. Whatever your reason, or its cost. I mean, the public cloud can be expensive, especially when you go out to scale. So, so the question is, OK, so they might be thinking, how do I bring it in? How do I bring that application into production? And so these are some of the natural questions that arise when you're talking about all these things together. So, simplistically, so you have your private cloud. We talked about that. You have your virtualization piece on the right. You have your public cloud here, and you have your OS there. So how do you bridge this gap? I think that's the question. But if there are two common pieces of technology, you got to think, or even before we get to the technology, two things at a very high level that you have to worry about really are application portability. How do I get applications from one platform to the other platform? And the second thing you have to worry about is data portability. So when you talk about application portability, the natural technology answer at a very high level is hypervisor. You need a common hypervisor to make that happen. And then to get data portability, you need a common or a shared storage platform. So what we are kind of postulating or kind of saying here is that the hypervisor and a common hypervisor and the shared storage are going to be kind of essential. You've got to start thinking about that as the essential bridge between all these things, be it your private cloud, your data center virtualization, and your public cloud. And obviously, there is the operating system, which is a common piece. So what are some of the Red Hat technologies that are playing here? Now we are kind of getting to the crux of the discussion today. Red Hat, how many, I mean, hopefully everybody is familiar with Red Hat OpenStack. How many of you are familiar with Red Hat OpenStack? Oh, that's good. There's a good show of hands. Red Hat Enterprise Virtualization is a virtualization platform. Show of hands. OK, everybody's aware of that. And then, obviously, RHEL. I won't even ask the question. So everybody is more or less familiar with that one. And then we have some Red Hat technologies which are on public cloud, such as OpenShift, for instance. So all these things, we said we needed a common hypervisor, and that is KVM. That is by far the most popular hypervisor technology, at least the open popular technology, and certainly popular on OpenStack. So, and that is a Red Hat technology. And then we have Red Hat storage. How many of you are familiar with Red Hat storage? Oh, it's good show of hands. OK, so anyway, so KVM and Red Hat storage is going to be kind of what we are saying is the glue that brings all these technologies together. Again, like I said, you will wonder if, for one thing, networking also is required, but we are not going to cover that here in this presentation at least. So at a very high level, so what does this integration look like with Red Hat storage and KVM? So on the left here is your, it's kind of a bit hazy up there, but anyways, on the left is your virtualization Rev cluster, if you will, right? And you have your KVM, the 3 nodes there, and the KVM is running guest. You show Windows as well as Red Hat Enterprise Linux. They are running that, and they are being managed by a Rev engine, which is basically Rev Manager on the left. And on the right, you have your OpenStack deployment, right? And you have your, for those of you, I mean, most of you are familiar with OpenStack, so that is Nova. And then you have compute nodes. And then the compute nodes is running KVM, right? And then on that, you have Nova instances or guest instances that are running, again, different operating systems. So that's the setup. Now, if you look at this, there are some services that OpenStack has standardized on, right? There is Glance, which is their image service. There is Cinder, which is their block service. And if you look at these 2 services, what they need is really shared storage. So this way, I mean, the shared storage is provided by Red Hat storage at the bottom here. It provides the Cinder data and Glance data, as you can see there. And Glance is the image repository, which obviously can not only be used for OpenStack, which you are familiar with, to boot from, but also you can use it on the Rev side of the house. It's the same thing. I mean, same thing with Cinder. You can attach volumes to guests there in your case of OpenStack, no compute nodes, and you can similarly do the same thing with Red Hat Enterprise Virtualization on this side. Now, some of this is work in progress. Some of this works today, and we'll cover all that a bit later. But at a very high architectural level, this is how we are achieving the integration. So as I said, the common piece, again, here is KVM, which is running on both sides here, like I pointed out. And the other common piece really is the storage piece, which export both the image repository and the block service. We'll not talk about Keystone, but Keystone is for security and for your credentials, and that's very important too. But we'll skip that in the interest of time. Keep going here. So we looked at a very high level. OpenStack, Red Hat OpenStack, Rev, and Red Hat storage, how do they come together? And now you've got to we kind of switch gears and ask the question, over the next 3 slides, I'm going to cover some of these technologies. Most of you are familiar, but just to give a one-page kind of overview of these products and technologies. But before we get there, I think we are asking this fundamental question. Now, if you're saying this has to be shared storage is so important, you got to ask yourself, what are some of the storage requirements to play in this kind of environment? The first one really, obviously, is no vendor lock-in, and that's pretty obvious, especially for many of you who attend Summit. You are already kind of bought into that idea that lock-in is not good, open source is good, open community is good, and not only for no vendor lock-in, but also it provides you innovation. So we need storage which is no vendor lock-in open. We need a commodity hardware base. Now, the reason for that is to take advantage of the x86 volume economics, right? I mean, nobody can beat the Intel and the AMDs at their game, and they can provide the best hardware at the cheapest cost. And so we want to be able to take advantage of that. So your storage wants to take advantage of that. The traditional storage vendors are way too expensive. Think about my own alma mater, Sun, and the big machines they used to have, once upon a time, 10, 15 years ago. So the third one really is the third piece you want is, we talked about we want data to be portable, right? So you have your applications which probably access data via different protocols, NFS for Windows, CIFS, SMB, and then they might have Web 2.0 kind of applications which want to use the object interface. So what you really want is that the reality is there will be different applications on different sites which will need all 3 kinds of accesses, maybe 2, but you need to have that. Providing unified file and object, as we call it, is kind of important. And then you want to manage them with a unified pane of management, which is pretty obvious. And then finally, I think this is the most important piece, and that is that OpenStack, all this we are doing because we want to achieve scale, right? I mean, private clouds, virtualization. You want to achieve scale. You want to achieve massive scale, and so you want a real scale-out technology, especially if you're going to use commodity hardware and you want to kind of stack them next to each other and grow it that way from small to large. You want a truly scale-out technology which is highly available, because this is storage, and storage is always important. You don't want to lose storage. It needs to be available all the time. So with that, let's talk about Red Hat storage and how it can kind of satisfy these requirements. We'll talk about that. Just to give a brief background about Red Hat storage, it was a technology that was started by Gluster. I see some of the original Gluster founders or early engineers in this room right now. It was founded back in mid-2000s, acquired by Red Hat in like 2011. Since then, we have kind of added and even Paul talked about it in his keynote today. We have contributed. We have hardened. We have made it better, and so that's Red Hat storage. And the 2 fundamental design principles of Red Hat storage really are distributed architecture to take advantage of the commodity hardware. So it runs on commodity hardware. It needs to be distributed architecture so that you can scale out. And then the other one is you need to provide file and object access or multi-protocol access, as I said earlier. So those are kind of, if there's nothing else you want to take away from this slide, those are the 2 things that we are good at and forms the basis of our design. It's deployed at scale at a number of customers. The one I'll mention really is Intuit. I think they are a public reference for us now, and so and they are Intuit are the same guys who do TurboTax, and many of you from the US are probably already familiar with them. So anyway, so they are one of the Red Hat storage customers who are deploying it in production. So that's a little bit about Red Hat storage and its history. In terms of architecture, Red Hat storage starts, this is, okay, oh, this is not going to work. So I experimented with that earlier, but obviously I couldn't get the technology right there. So if you start with the disks there on the right? So fundamentally, it is all disk drives, and you put a bunch of disk drives together in a commodity hardware I mentioned, and you form your RAID arrays, and we'll not get into exactly what we support and what not, but you can form RAID 10. Red Hat storage only supports RAID 6, but I mean, the technology supports other kinds of RAID configurations. But anyways, you get a volume, and then that's called a brick, right? And then what you do really is the brick is a fundamental unit at which Red Hat storage operates, and then we can take multiple bricks together and then tie them together to form a volume, which is the shared storage pool, and then you can actually there is a one connection that I missed was above the disks, you have your volume, and then above the volume manager, you have your file systems such as XFS or ext4. Again, Red Hat storage supports XFS, but the technology allows for use of other file systems too. And then on top of that, obviously, we build our shared volumes on top of that file system. Now, the big advantage really is that that file system is local, right? I mean, if you take XFS or ext4, it's local to that node. But with the Red Hat storage, you can go across nodes. And that's how you achieve shared storage. That's how you achieve scale, and then we can get into details such as how do you achieve, if you store data in both places, right, on that node and this node, then you achieve your high availability. If one node becomes unavailable, you have it available in the other node at a basic level. So anyway, so that's your cluster volumes, as we call them, and then they can be exported as multiple protocols. We talked about this, NFS, CIFS for Windows, Fuse is a native implementation, and then we have a RESTful API for object access, which incidentally uses OpenStack Swift. We'll talk about that a bit later. So most of you are familiar with Red Hat Enterprise Virtualization. With a high level, we talk about the Rev Manager, which is the manager, system manager, and then we talk about the hosts themselves, which can be RHEL, which has KVM, or it could be a Rev Hypervisor host. And so, Red Hat Enterprise Virtualization Manager has the concept of hosts, and then it has a concept of a shared storage called the storage domain there on the right there. That should do for the purposes of this presentation. In terms of OpenStack, most of you, again, are familiar with OpenStack, so I won't go a lot into detail. The most relevant pieces for us are obviously the NOAA compute, and then you have the image service called Glance. We talked about that. The object store itself is Swift, and then the block storage or the volume service is really Cinder. And all of that, as I said before, can be done on Red Hat Storage Server. We'll cover that in the next slide. And then we have these other pieces, which are also very important, but again, not needed for the purposes of this discussion. So how do we achieve this private cloud with Red Hat storage as the shared storage and Red Hat OpenStack? The idea really is, if you take that Red Hat OpenStack, we talked about the concept of hypervisor nodes. Those are the KVM nodes there. You can see them there. And then there is the Cinder, which is the block service, or the volume service, which is a service that can run on those nodes and basically presents volumes to those KVM nodes, and which can be then attached to guests that are spawned up in that from NOAA. So that's number one piece. So that's Cinder, right? And then, so there is a plugin. So the way Cinder service is built is that there is a plugin on the backside wherein you can actually put different storage vendors there. And to pipe it to Red Hat storage, you need a driver called GlusterFS driver. And so with that GlusterFS driver, the GlusterFS driver talks to the native client that I talked about earlier, the Fuse client, and then that's how that is plumbed to the Red Hat storage server. That's the Cinder part. Glance is kind of similar. The same idea. There's a Glance service, which is the image service. So the Glance service runs on the NOAA compute nodes, and basically the images are presented to the compute nodes, and then on the backside there is a GlusterFS driver, which then plumps it to Red Hat storage server. And then finally, we have obviously the Swift interface, which is basically the object interface. Similar idea. There is a Gluster plugin. Right now, it happens to be in Gluster upstream, but I know that some folks are working on getting that into kind of a more independent project. But in any ways, the idea is the same. There's a plugin, which is a Gluster plugin, and then that's how that connects to Red Hat storage. So how do you achieve Red Hat? Now, kind of switching gears a little bit, but it's not that different. The idea with Red Hat Enterprise Virtualization is also very similar. And the idea there is that there is Red Hat storage here. We need to provide shared storage. So Red Hat storage presents volumes to the hypervisor node that you can see there. It says x86 server. The hypervisor is running on them. It presents volumes through the Fuse native client that I was talking about. And then basically the hypervisor then can do two things. It can store VM images on that volume, right? It can use it as a QCOW2, for instance, image. Or it can do is it can export a volume directly into the guest, and that can be presented as a virtual block device. And so you can do both things. The advantage really of having your live VMs on a shared storage is that it allows for live migration. So if you're familiar, Red Hat Virtualization has the concept of live VM migration. So if one of the picturize this, if one of those x86 servers goes down, it can be migrated over. All that VMs running on that can be migrated over to this other one. But the common piece it needs is shared storage, because that's where the live VM is stored and being updated, and because of our high availability feature called AFR, that makes that happen. And then we have a common management. So that's kind of what you see there. Not only can you, for those of you who are familiar with Rev Manager, not only can you manage all those hypervisors and the guests there, you can also manage Red Hat storage and those nodes and the volumes and everything else from the same Rev Manager. So that's that. I think I skipped a slide here. But here quickly, I'm showing here a couple of things on this slide and next slide, and that is the main thing to remember is on the left there is the read, and on the right there is, this is, first of all, this is I/O performance for sequential reads on the left, and I/O performance for sequential writes on the right, and then the parameters are there. But what the most important thing to remember is that as the number of, on the x-axis, as the number of Red Hat storage servers and the Red Hat virtualization hosts, as they scale up, the performance also is scaling up, right? I mean, it's almost near linear performance, but that's kind of what you want. And this you can see both, not only in the case of sequential I/O, but also random I/O. You can see that scale up. And the reason I'm presenting that is because KVM, remember we talked about KVM. KVM is the common technology between Rev and OpenStack. And the idea here is to show that it scales well. I'll talk, next two slides are a little bit about the future. The first future really here is this idea of right now, so if you right now, so you have your KVM as your cluster, a bunch of KVM nodes. That's your KVM cluster, and then you have a Red Hat storage pool right here, and then today, what we do is that we said we use the native Fuse client, and then we use something called the POSIX FX, which is more general purpose storage domain to do the communication between these two. But in the future, what we are going to do is that we are going to have a block driver, a QEMU block driver, and then we're going to introduce a concept called a GlusterFS storage domain, something that we co-developed with IBM. And so basically, the advantage with this is that although the performance is good, what you saw in the previous, it takes it to a new level. That's what that does, provides more efficiencies. And then this other thing really is basically the idea of, some of you might be thinking, hey, why do we have, now we have a x86 server, I got 12 disks, 24 disks, 36 disks, whatnot, right? I mean, why can't I run a hypervisor there, and why can't I run storage, take advantage of the disks there, and also run the VMs on the same machine? So the idea here is to run the virtual machines and Red Hat storage on the same machine. Two advantages. One is it gives you consolidation, right? I mean, instead of 2 servers, you're using just 1 server. That's a big one, 50%. And the second advantage really is that if there is a VM that is running there which needs local storage, we can have that guy refer to that local storage, so it doesn't do any network hop. So it's a big performance improvement, and obviously reduces costs in your network equipment needed and whatnot. And you think about some of the big data technologies, Hadoop and whatnot, they need that. I mean, they have massive amounts of data which are localized on different commodity hardware, and they need the data to be locally available to be most efficient. So that's the idea. So this kind of takes it to the next level. From the previous slide, I know the diagrams are kind of not the same, but the idea is the same. I mean, you still have Red Hat storage and the guests running on the same KVM host. But right now, what happens is that, like I said, once a cluster volume is presented on that KVM host, it needs to be exported into the guest as a block device. Either you do that, or you just use NFS or something like that too. But the problem really with block devices is that they are kind of hard to manage, and then you're creating more hierarchies, right? It's a file system, then you're connected to a block, and now you've got a file system in the guest above that, and you've got to create XFS or whatnot. And so there are too many hierarchies, difficult to maintain. That's one. And the second really is that if you use NFS, you're doing round trip. So if the data is local on that Red Hat storage node, and the Hadoop guest wants it, it's still going to go out to the network, to the NFS server, and come back. And so you don't want that either. So what we are saying really is that, instead of presenting blocks or trying to use NFS directly, present file as a first-class citizen directly into the guest, and that is called as file as a service. So the advantages are pretty obvious right there. The use cases really are you get your virtual NAS. Like I said, things like Hadoop, which have local data affinity, benefit immensely from this. And the third thing that I didn't mention is that you can do tenant-specific shares. I mean, it's easy to say that okay, this particular file system and this particular file is only available to this guest, and I'm only going to export to this guest. And so you kind of go into this, multi-tenancy becomes easy, especially for those of you who are thinking of providing that kind of isolation in data. So that's that. So I'll just summarize quickly. So what we said was this is how we are going to integrate Red Hat storage, virtualization, and OpenStack. The main advantages, really, the benefits are the scale-out is a truly scale-out platform. It's highly available, enterprise-ready, and it's open. With that, I'll hand it over to my colleague, who is going to talk about a little more on the ROS Rev integration.
OK. I hope you can hear me. So thank you, Tushar. A few things I want you to keep from Tushar's presentation. And we talked about earlier today about connecting all the worlds. And being at Red Hat actually is a privilege, because we can impact both RHEL. We can impact both the virtualization, and we can impact also the cloud. And there's a big challenge, because it's not just looking at, OK, how each one of these technologies is going to evolve by its own, but what are we going to do in order to enhance that? So if I'm looking at the virtualization roadmap, what changes do I need to do today in order to support the cloud needs of tomorrow? OK, so keep that in mind as we go forward. We're basically looking at different pieces we're putting together. So we talked about the storage. We talked about bringing the storage into the OpenStack layer. Now let's go back to the hypervisor layer. Now, how many of you know OpenStack? Raise your hand again. OK. How many of you knows how OpenStack creates a VM? Few hands. So let's talk about that, and let's talk about the similarities and differences so it gives us a clear understanding. So there, Hypervisor, okay, let's look at the Rev enterprise virtualization, and let's look at Red Hat OpenStack. They do similar things, right? So in a sense, both deals with VM lifecycle deployment, both have VM repository, and both have storage services. However, what's the difference? Where should I just deploy virtualization, and when should I actually go into cloud? And the answer is pretty easy. It's scale, right? So OpenScale basically automates the largest data center by abstracting the resources. By extracting, so we'll see where actually the abstraction ends and the hypervisor beneath starts to work, right? So that's the key. They both tend to address similar problems, right? I'm virtualizing physical environments. I have the same, it doesn't matter what scale I'm doing it, right? So if it's bare metal, I'm going to bare metal to the cloud or to the virtualization, I'm facing the same problems. However, I have to address them in different levels to support that. And in a sense, is there any musicians in the crowd today? Okay, so I'm playing the sax. And from now on, when I play the sax, I actually have to put a -1 CD to play with, because I can only hear myself. It's like a rock band when you have OpenStack as a Fender electric, very cool guitar, right? But you still need a rhythm section. You need the drums, you need the bass, and this is how we basically bring it all together, okay? So let's zoom in. And I just asked the questions of how OpenStack creates a VM. So if we drill down the technology, we'll see when you create an instance and would like to spawn a VM, what happens behind the scene is that actually OpenStack doesn't actually create the VM. It doesn't have to. We have a hypervisor level, right? We have KVM. It basically invokes the hypervisor-specific libraries such as libvirt to do that. Okay? So that's the abstraction layer we talked earlier. Rev, actually, on the other hand, has a full-blown features that we actually took KVM, right? And we empowered KVM with all the missing things to bring it to the enterprise. So the latest edition we actually released today in 3.2 is be able to do officially storage live migration. Can you do storage live migration in OpenStack? Okay. Another cool feature we're adding in the future release we're currently working on is actually the backup and restore, working with ISV partners. We're bringing more ecosystem also to the hypervisor world. So what are the use cases? Why should where is this applicable, right? We talked about the bridge earlier when we have to walk from the traditional virtualization, I still get used to it, right? The notion. So traditional virtualization up to a private and hybrid all the way to public cloud, right? So what the steps and what the ramp off that I can offer you to do today. So let's look at the use case. One of them actually Tushar touched earlier when he talked about the Hadoop. So how many of you know big data and Hadoop? Quite a lot, right? So you can run Hadoop without cloud, but how cool it is to give your developers Hadoop as a service, right? So if you would like to roll Hadoop as a service, and I encourage you actually as a follow-up to this presentation, look up on the web the Savannah project. Savannah is a Hadoop as a service project for OpenStack. Okay, so that's already where we're going with this. It's not just big data on the traditional, it's big data on the cloud, right? So what are the needs when we're of big data on the cloud? And Tushar actually mentioned and touched the fact that why do we need to copy things over HDFS, right? We can actually use one namespace barrier. So that's actually only the start, but we're working now on the further integration and further features that we need to empower. So we are really, really at the start. This is the first edition of OpenStack, right? On Red Hat OpenStack, on Grizzly, just the first. So this is our baby, in a sense. Think about what happens when it turns out 5 and start play and break things around their highs, okay? So this is where we're going. So this is just the start. Another use case is actually scaling down. Yesterday I had a talk with over our booth with a customer that tells me, I have Red Hat storage and I have Rev. First of all, I have, and this is a customer that would like to roll many of this compute on a branch office level for a retail company across the nation. And actually looking for a really cost-effective solution. So we talked about, actually he touched that before. Tushar mentioned that we can actually today roll Hypervisor and the Reddit storage server on a single physical server, right? So think about it. This is cool. You can go home and load Hypervisor and Reddit storage and then take another one. You have a full cluster. I'm good. That's it. Open source. I don't have to pay anyone anything, right? Maybe just Reddit the subscription because I need support if everything breaks, right? But other than that, this is already where we are. This is commodity, right? We have this basic stuff that we can guarantee that we have replications, both synchronously, asynchronously, and all our VM data is there. Now, how many of you use Hypervisor today, and how many of you feel the need to replicate it? That's your solution, right? So this is basic stuff, but we're only getting there right now. This is my favorite, actually, piece of this talk today, and the reason is I'm actually going to demonstrate this. To those of you who actually started to play with OpenStack or even took it to the next level of testing it and looking at it in your environments, one of the questions that raised is basically the life cycle, and this is where I'm going to give you an example of this third line over there. So think about the DevOps use case. When you develop a new software, it's up there on a cloud, and it's easy because now we have all that marvelous tools. We can do everything. We can provision instances and test our new development. And then we basically move it to the next levels of testing, staging, right? But then we would like actually to take that, OK, I'm done. We can roll it to production. How do I roll it to production? And where do I roll it to production? So we saw earlier that the hypervisor is pretty much where my production resides. I need to be able to move that VM image to production. Is it possible just off the box? No. We need to make it possible. We need to actually combine the repositories. So I have a glance repository or OpenStack. Why not use it for the hypervisor? Okay? So this is exactly what we're going to do. So we can actually, if you think about it, OpenStack can enjoy automatically off the shelf with all the images and VMs you already have in your environment today. So if I roll my production on a hypervisor and I have all my application there, I can actually load it to OpenStack. What does it mean? My hypervisor sits in a specific data center in Boston, and I would like actually now to use that VM in New York. That's what it means. We're actually taking our data center and making it available elsewhere. That's basically moving from virtualization to the cloud. That's why it's important. Okay? The other way around, and this is why I gave the example earlier. So Rev actually can import and export the VMs back to OpenStack. And I'm going to show you a little demonstration how it works. This is actually already done upstream, so I'm going to demonstrate it on Overt, and it will be supported in the next version of Rev. In the meantime, let me just start the summary, and then we'll do the demo, which is pretty neat. So I advise you to wait for it. So IT is basically, we talked about we're in the middle of the revolution right now. This is when things happening. We already changed the way we consume. And we're changing the way we operate, right? We can do development projects already on the cloud today. We're seeing more things moving to the cloud, right, as a service. That's where we are today. But what this actually requires from us is actually to start building the bridges between this type of technologies, because it's not off the shelf. It's not working right now. We need to invest in it. We need to actually use our large community of open source to make it happen. There's tons of room to innovation. This is just the start. I can tell you that the work we're doing just on the storage side today to certify all the ecosystem of vendors on the storage side is tremendous. And I think you heard that also on the keynote. And I think that's one of the added values that Red Hat brings to you as users at the end of the day. When you roll your OpenStack or virtualization, or doesn't matter where you are at the stages all the way to the cloud, we make sure it actually works with anything you plug it on. OpenStack is a pluggable infrastructure. It does abstraction, okay? But we have to make sure that whatever you connect to it actually works, okay? So that's the main key. Do we have it? So let's log into the overhead management. To those of you who haven't seen it, this is how our Hypervisor looks. This is our upstream version of Rev, okay? So we log in. The first thing we're actually going to do is create a new storage domain. And we'll be able to actually select a new entity, which is now the OpenStack glance. And this is what we're doing in the demo here. And we'll basically specify a name for it and a glance URL, as well as a relevant tenant name from OpenStack, right? So basically, we're actually taking an image that we have deployed somewhere in the OpenStack data centers, right? And we probably want to move that to production. Remember the use case I gave you for the DevOps with all the layers. So now we have a glance domain. And if you look at the images, we see two Fedora images actually imported from OpenStack. And what we'll be able to do is now list these two and map them all the way up to a VM in the hypervisor level, okay? So we're setting quotas, and we'll be able to select the relevant data set that you want to import that image in the hypervisor. So now we'll see the two glance images just imported into Rev over it, and we'll be able now to take them and build a new VM and actually attach these images that came maybe anywhere on the OpenStack instances from the different data centers to the specific data center hypervisor. Okay, so this is pretty cool. It's already working, as you can see, and now it basically gives you the import. The same mechanism actually will allow us also to do export. So we can export back to from the hypervisor to OpenStack. So this is basically we're attaching a disk to a VM and pretty much done. So now we have a glance image. We can roll Fedora with all its environment already on the hypervisor. Simple as that, all right? And again, you can, same thing, we'll be able to leverage from OpenStack, from the hypervisor, but both ways. One repository, shared. Traditional, future. Okay, this is where we're going. Okay, so this is how it physically connects, virtually connects. Questions? Yeah.
So moving forward, it's really interesting. You're going to bring block storage into cluster and now Red Hat storage. Do you have any concerns, or are you going to provide any information about how to really tune that environment, make it the fastest possible block read? Because one of the concerns is, at the end of the day, still, the more we grow the OpenStack cloud, there's a good requirement of very fast block I/O.
Yeah.
Move to the purpose-built objects everywhere.
Yeah. So.
Yeah, absolutely. I mean, you know, that's kind of, I mean, when we talk about, the innovation, everything is going to happen upstream. But when you talk about best practices, it's talk about tuning, you know, all those things. That's what Red Hat provides, right? I mean, that's what we provide to our customers, because when we say enterprise, that's what we are saying. I mean, these cannot be just deployed willy-nilly for production workloads. They need to be tuned, and we invest in that. We have an entire performance group. In fact, one of the presentations is going to be entirely about performance tuning Red Hat storage for different kinds of workloads. I think it's tomorrow or Friday morning. But anyways, that answers your question, hopefully. Any other question? There was another question when I was not listening, so hopefully that was... OK,
we're still around, and we're around during the
no, I mean, we still have plenty of time, so
yeah.
we'll be there for a few more questions if you have any questions. Yeah, there's one in the back.
I had heard that there might be plans for a Nova plugin for actually having OpenStack control Rev funds. Is that true?
I not completely heard the questions. Was that basically?
Like right now, Nova's set up to control or schedule launching VMs on physical hypervisor. But I heard that there might be plans for having OpenStack have a plugin to actually have a virtual node that's actually underpinned by a Rev cluster.
So there's a start to the upstream actually work around that. It's basically around Nova, providing a Nova driver. So yes, there is work. I cannot tell you when it's going to be integrated or not, but we see a lot of work around different areas. So this is one of the areas. Yes, absolutely. No, it's upstream on OpenStack. Yeah. So to those of you who haven't heard, so HP is currently working on the driver. Okay. So you can find online. It's already posted. Yeah. Okay. Any more questions?
Yeah. Does OpenStack work with, like, I know you talk about third-party alternate vendor.
Mm-hmm.
Does OpenStack work with sort of other arrays like UT?
So I mentioned that earlier, and this is something I'm really proud of. We actually worked very hard in the last year certifying vendors, and most of the vendors from the block level already have their Cinder plugin certified with us. If it's not certified yet, certainly the big companies already certified, and the rest are in the pipe. And this is also not just for block storage, but also for quantum certifications, not just Cinder. Yeah. So this is a big part of what we do, making sure that it actually works. Okay, thank you very much.